Hello, welcome. Thanks, Matt, for the great introduction. My name is Taylor Brown. I'm a lead program manager in the Windows and Devices group, and I'm here today to talk about Windows Server containers and Hyper-V containers. So the first big question I think we have to look into is, why containers? Why do we even care about this next hour? Why am I even listening? So containers provide us some fairly interesting things. One, they're really just enough virtualization for a lot of the things we're talking about today. And what I mean by that is that containers are really a form of virtualization. They're really an operating system level virtualization. But for a lot of the applications that we're talking about now, that's actually the amount of virtualization we need. So we get a lot of the benefits of what we would think of as virtual machines, transportability, the ability to run them in different environments, all of these kind of things. But we get them at a lower price. We get them at lower amount of resource usage, so higher density. We get them at faster startup times. And we get some other advantages too. Containers are really highly portable. They're designed to be distributed. The way that you actually interact with them dictates and predicates an ability to move them around and run them in different environments. They're really designed around automation. And we'll talk about this as we talk about how to build containers and how to operate with them. But they're really designed around high levels of automation, highly repeatable, and great for DevOps environments or environments where we're really trying to do more continuous integration, continuous delivery, which leads us to faster and faster deployments. They're also immutable in the sense that what that means is they run the same way every time. So if I run a container image on my laptop, it runs exactly the same way on the production server and in the production server. And they can be versioned. So if I make a mistake, I can simply roll back to the previous version without having to do some very complicated uninstall process. And we'll kind of dive into a bunch of these as we go through the rest of the next hour. The other big question is, okay, how do I actually use containers? What is the way that I actually interact with these things? We're going to kind of break this down into a couple pieces. The first, we're going to talk about how you build a container. How do I actually make a container, right? Then we're going to talk a little bit about how you actually run a container. And notice these are actually two different topics, and we'll kind of get into why we've separated these topics out as well. Then we're going to talk a little bit about distributing containers. How do I actually distribute these things? And maybe distribution, you think about like, wow, okay, am I going to put these up on, some website or some store? Am I going to sell them? Well, maybe you are, but distribution can also just mean, how am I going to push these into my production environment? How am I going to move these from pre-production into production, or from one site to another site? And then we're going to talk a little bit about how we actually go about managing containers. What are the tools and some of the techniques around managing containers? All right, so let's dig in. Let's go right into building containers. And the important part about thinking about building a container is you're not actually building a container. What you're actually building is a container image. Okay, well that begs a question. What is a container image? Well, a container image is really a template for containers. It's a read-only image. You can think of it almost like a virtual hard disk for containers, although it's actually file-based as opposed to block-based as the case for a virtual hard disk. And it has a bunch of configuration settings in it as well. So it's got some defaults that come along with it. If we actually look at the way that, let's say, Docker implements this, it's actually a combination of some metadata and some layers. Now, image metadata is things like what's the name of the image. So that might be my IIS server or my website. That's some information about like how many processors would this thing like to have? How much resources would we like to have this container consume? What network demands does it have? All of these kind of things can be built into that image metadata. And then there's layers. And the layers actually have their own little piece of metadata that just says some stuff about what's in that layer. But this is where the actual payload is. This is where the actual files and registry configuration and things like that live. And we can notice that there's actually multiple layers within a single image. And that's actually a pretty important point, and we'll dig into exactly why that matters in just a moment. But think of an image as basically a template of all of the data and the configuration needed for a container. You actually create these images in a couple different ways. You can create them manually. So you can actually run a container, make some changes, and then save the image, just like you would with a virtual machine and a virtual hard disk, right? You'd start up a virtual machine, you'd install some files in there, change some settings, shut down the virtual machine, you could copy that virtual hard disk around. You could certainly still do that with containers, but there's actually an even better way to do it, and that's using some automation. And so the Docker way of doing this is what we call a Docker file. A Docker file is what allows us to automate the creation of an image. And then there's actually a final way you can get an image, and that's actually to pull it from a repository. And we'll talk about repositories when we talk about distribution, but that's the other way that you can get an image. So there's three ways. We can manually create it, we can create it with some automation, like a Docker file, or we can pull it from a registry. So let's talk a little bit about the Docker file, or about the manual creation, sorry. So this is kind of what this ends up looking like on a system. So we start off with what we call the container OS image. The container OS image is basically a clean copy of Windows Server. So we have two of these that we offer, Windows Server Core and a Nano Server container OS image. And so if you actually open this thing up and look in it, it's a WIM file, and it's basically just a clean copy of Windows. All containers start from one of these two. Right? We talked about images being a template. This is basically the base template of a container. So we look inside that, we'll see a Windows directory, we'll see a program files directory. If it's Server Core, we'll see a program files x86 directory. We'll see the normal files and registry that we would see inside of any Windows machine. When we actually start a container up, what we do is we create a sandbox that container is running from. And what that sandbox starts off with is just a transparent representation of the container. So if we look at our image here, what we're saying is this is the container OS image. We're reflecting all of that into the sandbox. The sandbox doesn't really have these files, but it has representations of them. If we looked inside the container, we'd see all of those files. Now, when we do something like, in this case, we're going to say, well, we're installing IIS. Well, one of the things that installing IIS does is it creates the inet pub directory. That inet pub directory is a real directory, and it lives in the sandbox. It's a real thing that's living in this sandbox. Now, the rest of the files don't live in the sandbox. They are just kind of figments of our imagination. They're pointers to those real files. When we stop the container, we can then do what we call a commit. And what a commit does is it moves all of that information from the sandbox over to a new image. And now that's a read-only image. That is now a read-only image of IIS in this example. And so all of the pointers still point back to where the container OS image is, and we still have a real directory located there, right? So why is this important? Well, I don't really just want an IIS server. I want an IIS server with something cool inside of it, something like Ninja Cat. And so if I create a new sandbox off of that IIS image, now I can copy in my Ninja Cat website. And again, these files just live in the sandbox. They're represented off the IIS image and all the way back to the container OS image. They're just pointers back to these things. And this actually allows me to now commit that image and have a Ninja Cat image. Right? So now I've got three images. I've got a container OS image, which is basically Windows. I've got an IIS image, which really, in this example, just has a directory in it. That's all it has, right? So it's incredibly small. And I've got my web app image, which just has my Ninja Cat website inside of it, right? Again, very small. Now, I can't use this image without this image being present because they have a dependency on each other. And I can't use this image without the container OS image being present because they have a dependency. But when I have all three of them together, I can run a container off of it, which has my website in it. Pretty neat. But let's talk about how I'd actually do this with a Docker file, because that's really the more appealing way to do it for a number of reasons. First, it's an automated way to do it, right? So it's repeatable, highly repeatable. I can do the same thing over and over again, and I'll get the same result. I don't have to worry about, oops, I forgot to run this command or that command. If you forget it, you forgot it in the Docker file, it's going to break every time. If you got it right, it's going to run the same way every time, right? These Docker files are consumed when we do an operation called Docker build. This is just a command we issue to the Docker engine that goes off and builds one of these container images consuming that Docker file. This also enables some really amazing automation through things like the Docker Hub and Docker Trusted Repository that we'll talk about later. But the important part of this automation is that if one of these other layers changes, so remember our Ninja Cat is dependent on this IIS image, which is dependent on this container OS image. If we updated the container OS image, like there's a patch for it, a new one of these is generated, the Docker Hub is smart enough to go, wait a minute, this guy was dependent on that. Let me rebuild him. I will run the Docker file for that image again. Okay, that got changed. Now this guy's been updated. Oh wait, this guy needs to change too, and it'll run the Docker file for that as well. Right? So as these things happen, you just run through the same exact processes again. So the same continuous integration and delivery that you did for maybe making a change to the website applies to the infrastructure as well. Anything that's unchanged between different runs is actually cached. And that's actually where that layer construct comes into play. So I'm going to do something here. I'm going to actually back up a whole bunch of slides just to highlight this point. So if we remember back to this slide, we had these different layers in there. If I only change one thing at layer 2 or below, I don't actually do any of the stuff that was just going to generate layer 1. It's just cached. It stays the same. Only the things below that actually change. And so it makes actually building these things incredibly fast as you're doing rapid development. So back to where we were. Here's an example of one. So this is an example of creating an IIS image. So what we've said is from Windows Server Core. So Windows Server Core being this container OS image base layer that I started from. And then I'm simply just saying run PowerShell and add Windows Feature Web Server. That's all I had to do to make an IIS image. Now the other option, and we'll talk about this in the repositories, I could have just pulled this image down from the Docker Hub because we already have one created for it. But now let's look at the web app image Docker file. So in this case, I'm now saying from IIS, so I'm saying from the image that was created here, just add the NinjaCat directory to inetpub NinjaCat. That's just doing a copy operation to copy these across. Right? And at the end, I've got a demo that kind of walks through this in an example form, but that's really as simple as it is to make a Docker file. It's just a set of instructions, just like a make file. In fact, that's where they got the name from. So now let's talk a little bit about running containers, more of the exciting part of it. So the basic execution model for running a container is just to do a Docker run. So a Docker run creates and starts a new container. Right? So again, we're starting from a template. So we start from an image. So I specify the image name, and I can start a container from that. There's a bunch of runtime options that I can specify. I can say if I want it to be an interactive container or if I want it to be more of a daemon or background service container. And so if I was doing something like a manual build process or debugging something or troubleshooting, yeah, I'd set it for an interactive. I would pass the flag to say, yeah, give me an interactive session to this container. If I wanted it to be a service like a website or a SQL image or something like that, I'd run it as a daemon. Right? I can specify things like network port mapping. So I can say, map in port 80 from the container back to the container host. So I can pass that through to a load balancer or something like that. Right? I can specify volume mappings. And what volume mappings allow us to do is to actually persist data outside of the container. So I can actually take a directory on my host and say, this directory, let's say d:my container data, I'm going to map that into the container at c:, data. And anything that's in that directory on the host will show up in the container in the c:, data directory. Anything that's changed in c:, data is going to get reflected right back to the host volume. I can specify the name, both the actual container name itself, which may be not all that interesting, but more interesting would be the host name. So I can call this thing Taylor's Cool Web Server or Taylor's NinjaCat server if I wanted to. And these are just some of the options. There's literally 70 or 80 different options you can specify at runtime for containers for various purposes and needs. Some of those include resource controls. So I can set things like how much CPU this container is allowed to use or how much memory this container is allowed to consume as it's running. I can specify things like disk quotas. So we're working on enabling some new features in Docker for specifically for storage quality of service. And actually you can participate in that if you've got feedback on it. We're opening that up as a proposal on the Docker GitHub page, and we'd love to have people participate in that. For network, we have egress network quality of service that we're adding as well. So a bunch of different resource controls. And again, all of the disk and registry changes that are happen while the container is running are just captured in that sandbox, right? And you can either commit the sandbox or you can throw it away at the end. Now, one container is interesting, but most applications we have today are not single server applications, right? We have database tier and a middle tier and a web tier and a web service tier and an admin tier, and lots of different things, right? So composition and orchestration becomes pretty interesting. And in the Docker world, there's two tools that we use for that. The first one is Compose. So what Compose allows us to do, and this is an example of a Compose file over here, is it defines a multi-container application. So it says, hey, my application, in this example is just a website and a database, my application needs these two services to run. Without both of them, it's not really useful. And so it's a mechanism for us to describe the application as a set of containers. So in the example here, I've got a single web server container and a database container, right? Now when I start my application, I actually start all the containers necessary to run that application as one operation. Similarly, if I want to stop it, I can tear them down as one application. In fact, I can build them as one application as well. So I can do a Docker Compose build, and it will build both those containers at the same time, right? I can also scale independent tiers of it. So if I have a web tier, as I do here, I can actually say, you know what, I need more of those web servers. Please scale that up and give me more of them, right? Now, Compose dovetails right into what Docker calls Swarm. Swarm is an aggregation tool, so it allows us to aggregate a bunch of container hosts together as if they're one. So I can take 10 virtual machines and say, oh, I'm going to run Swarm against all of these, pretend that they're one. And so when I actually run my Compose commands against that Docker engine, it's really a virtual Docker engine that represents 10 different container hosts, and it'll spread load across them in a couple different ways. There's different scheduling algorithms you can plug into Swarm to dictate how it actually schedules things out. I can also do things with tagging and anti and affinity rules. So I can say, yeah, please don't ever put the web servers on the same node. I want to have multiple web servers so that they actually scale out. Another way that we're using tagging is actually to identify Linux versus Windows hosts. So Docker supports both Linux containers, which is actually where it started, and Windows containers. And so tags are actually a way for us to specify, yeah, that's a Windows image, please run it on a Windows server, versus, yeah, that's a Linux image, please run it on a Linux server. So that's not the only orchestration game in town. The other one that we've stood up in Azure is Mesos, or Mesosphere and Marathon. Now again, this is an aggregation of container hosts. It's got a nice web-based UI. We've got a little example of the web UI over here. Where Mesos really shines is in a couple areas. One, they've got a really nice service launch and discovery module. And they've got a very proven and reliable scalability architecture. They've been around for a very long time. The code base is fairly mature and has been tested at fairly high scale. Where Swarm is a relatively new orchestrator comparatively. And so it hasn't been proven at the same scales for as long as Mesosphere has. Now the Mesosphere Marathon integration utilizes the Docker command line to run containers, so it actually calls the Docker engine, so the same Docker container you build can be utilized by that. Now there's a couple other ones I'm not mentioning here. Kubernetes is one that's particularly popular as well. We don't have Kubernetes in the Azure Container Service, which is why I didn't mention it here, at least at this point. But Kubernetes is another orchestrator that you can use for running an application based on containers. So now let's talk a little bit about how I would go about distributing a container, right? Okay, so I've figured out how to build it and I can run it, but how do I actually move these things around? How do I distribute them? Well, the answer is an image registry. Sometimes you'll hear people call these repositories. A repository or registry, it doesn't really matter, but I'm using the term registry here. So what is a registry? It's really a way to discover, store, and distribute container images. So it's basically a server that has some sort of file backend, and I can push a container image into it, and I can ask that service, hey, what container images do you have? And I can pull a container image back down from it. Right? That's pretty much what it is, fairly simple. Now, as you talk about scale and high availability and all of these things, it becomes a little more complicated, but or security and authentication. But at its core, it's a file server with some discovery protocol around it. There's a couple options to talk about for registries. There's the Docker Hub. Now, the Docker Hub is a cloud service that's provided by Docker Incorporated, Docker, the actual company Docker. They have both private and public content. So what people are most familiar with is their public content. So I talked about earlier, hey, I could just pull that image from the registry. Well, that's what I'm actually meaning. So if you look at the Docker hub today, you can go to hub.docker.com. There's thousands and thousands of container images that people have put up there to share. Most of them have a corresponding Docker file that describes what they do. And like most things, there's a collection of 30 or 40 that are the most popular. But a good example might be Node.js. So I can go to the Docker Hub and I can get the official Node.js image or the official MySQL image, the MySQL image that was pushed up there and maintained by the MySQL team. And instead of actually building my own, I can just say Docker pull MySQL and it'll just come from the Docker Hub's private registry down to my machine. So I get that nice building block. I don't have to build my own. Now, if they find a security bug or they do a feature update or something, they'll push a new version up to the Docker Hub. And like we talked about earlier, container images are versioned. So if I want to stick to a specific version, I can do that. Or I can say, just always give me the latest version. Completely up to you as you author your Docker file. Now they also have private repositories up there, so you can pay and get a private repository that is controlled by you. You provide access controls to it, you decide who can access it, how many images there, etc. And if you go look at the Docker Hub, they've got all the information about the pricing models and how all of that works. Now, as I talked about earlier, this is an area where we have automated build support. So if an image is pushed to the repository, you can subscribe for automated build support. So when a change happens, they'll rebuild the subsequent images. So let's take an example of Linux to start with. So say I built my application on top of Node.js. Well, the Node.js image is built on top of, let's say, a Debian distro. There's a new security update for Debian. That means a new image gets pushed up. That'll automatically trigger a new build of the Node.js image. Then if I've had my Docker file up there, my application will get rebuilt as well. And they've got webhooks to actually trigger and inform you when this occurs. So you could take that image, run it through some testing, and push it into production without having to worry about a huge gap between when a security issue is identified and when it's actually fixed in production. Right? It minimizes that gap considerably based on the fact that each party's kind of doing their part of it. Now, the other option, if you're not a cloud user or you want some additional controls around it, is a Docker trusted registry. And what this is a private registry. It's either on-prem or in the cloud. And when I say in the cloud, I mean it's your virtual machine that's running this registry, so it's a virtual cloud. And we have these available in Azure today, so you can go to the Azure Marketplace and deploy your own Docker trusted registry. It's got a web-based management experience, has Active Directory and LDAP integrations, a number of other things as well. And so if you don't want to use the Docker Hub, you want to have a little more control, then a Docker trusted registry is the thing for you. Now all of these are, again, just registries. And if you want to, the Docker registry is an open source project. You can build your own. So in fact, it actually comes as a Docker container, so you can actually run the registry in Docker. So it's kind of a Docker in Docker kind of thing, but I digress. So registries are the way that we actually distribute images. And this is a very key component to the whole story. Now, remember earlier we talked about layers. One of the things that's kind of neat about the registries is they understand layers. So if two images actually had the same layer in it, so maybe I built my layer by saying, PowerShell install web server, and someone else did it with DISM, but the result was exactly the same. Well, guess what? They're going to be the same layer. They're going to have the same result. They'll get kind of deduped in the Docker registry. So there's only one of those up there. If I already have one, I don't pull it down. So it's a pretty neat system overall. Now let's talk a little bit about what we have in terms of some management for containers. So a couple management monitoring tools, and there are a ton of management monitoring tools for Docker. These are just a couple that we're going to touch on. So the one from Docker is what they call Docker Universal Control Plane. This is fairly new. They announced it last year at DockerCon Europe. It's a nice web-based UI. It manages container hosts. It manages container-based applications. So we talked about Compose, understanding all of the containers for an application. Well, Docker Universal Control Plane understands compose. Makes sense. Same company, same project. The ideas carry across. It also understands container repositories and images very, very well as well. Again, this has a nice role-based access control mechanism, integrates with Active Directory and LDAP, so you can do things like the IT department has permissions to all of the hosts, the developers only have permissions to the slow, crappy host in the corner. Unless they complain, then we'll give them access to another one, but it's all based on access control mechanisms. So you can have all that fine-grained control. We also have an offering from the Microsoft Operations Management Suite. So OMS for those that have been paying attention to some of this stuff. And this is really a monitoring solution for Docker. And so what this allows us to do is monitor things like the syslog events. So all of the things that Docker logs, performance metrics, how the containers are performing. And then I call it container data, but it's really things like, where are the containers running? Am I running all of them on the right site, on the right server? Have the images been deployed the right way? Am I running the newest copy of the image? These kind of things can all be bubbled up through OMS and the Operations Management Suite. And expect to see more in that framework as we evolve. And certainly your feedback helps us refine what is the most important things to be adding to that. So just a couple of the monitoring and management tools that exist for containers. So we've talked quite a bit about Docker, but let's actually go into some of the pieces and components that make up Docker and kind of where the line is between the operating system and Docker. So let's talk a little bit about some of the Docker components. So we've got our infrastructure at the bottom. So this might be, this is the operating system or any number of plugins. So these, this could be operating systems running in a cloud. It could be operating systems running locally. For this particular slide, it doesn't really matter. The gut of Docker is the Docker engine. So this is the thing that understands how to run containers. And we'll deconstruct this in a moment, but this is the core of Docker. On top of that, we've got a couple different components. So if we think about our developer workflows, and I put developer in quotes here, developer really starts to expand to not just the guy behind the keyboard running whatever language of code he's writing, but this is actually now becomes the operations team as well, as they're developing container images, right? So developer in quotes. And this is the Docker client and Docker compose. Right? Those two pieces we talked about earlier, Docker client being the thing that I actually issue commands to, compose allow me to stitch things together. Then we talk about actually how we ship containers out, and this is where the registry services come along, right? And so we talked about the Docker Hub and the Docker Trusted Registry as the ways we do that. And then running containers, so the Docker Cloud, and we'll talk a little bit about Docker Cloud in detail, but Docker Cloud is effectively a public cloud offering of the Docker Universal Control Plane. So I can go to cloud.docker.com and create a management experience without actually having to run one on my own environment. And then Docker Universal Control Plane being the thing we talked about earlier, where I can run this on-prem. And actually, the way that these line up, this top one, Docker Hub and the Docker Cloud, that's what they call Docker Cloud. It's the combination of the hub and this cloud.docker.com management infrastructure. And where this actually plays is this talks to things like Azure, or if you're an Amazon customer, AWS, or if you're a DigitalOcean customer, DigitalOcean, and it creates container hosts in those environments for you. Then there's Docker Data Center. This is your private on-prem or virtual cloud deployment of Docker. And so this is the Docker Trusted Registry and Docker Universal Control Plane. Now again, all of these build on this Docker engine. And so if we look at Docker Data Center a little more specifically, again, we have Universal Control Plane, Trusted Registry. There's actually Docker Swarm in the middle of this. So Swarm is the thing that's aggregating all of these Docker engines together from the different nodes, whether that's on a private or a public cloud. And then we have our Docker client and compose. And then we have a number of places where partners can interact with this. So there's monitoring plugins, there's network plugins. So network plugins is actually what allows us to do fancy networking stuff like software-defined networking. There's volume plugins. So we talked about mapping volumes across. Well, there's actually a plugin interface for that so that I can do cool things like, hey, when this volume gets started, don't actually just start it from d:\whatever. Go pull it from the blob store in Azure. You can write a volume plugin to do that kind of stuff. Active Directory integrations or login integrations. There's actually a number of other ones as well, but these are a couple of the big ones that exist within that. So now let's dig into a little bit of the architecture on how the Docker engine works and kind of where these boundaries lie. So we'll start off with the operating system. So the operating system is really where the container runtime exists. And so in Windows, we've got a container runtime now. That's what we're building for Server 2016. Linux has a container runtime as well. And then there's the container development and management tools that go on top of that. So that's actually the Docker engine, Docker Swarm, Registry, Compose, and the client that build on top of that. And then Universal Control Plane that kind of builds on top of these pieces. Okay, so let's dig into this a little more in depth. We'll start with Linux, right? Because this is where a lot of this started. Containers started initially in Linux, so we'll start there. So we've got our operating system box, and we've got our Docker engine box. The key pieces in the operating system are a couple different technologies. Control groups, and these are C groups is often the name for them. So these were actually something that Google built for Linux and put into the Linux operating system a number of years back. And what control groups allow us to do is do things like resource controls. So I can say this set of processes only allow this much CPU. Don't let them have any more. It's also a nice aggregation point. So it understands things like, oh, that process spawned another process. Well, we're going to keep that in our same control group. Okay. Then we've got namespaces. Namespaces was something that IBM started adding to the Linux kernel a number of years back. And what namespaces allow us to do is to do things like virtualize the processor, the process table, the PID, virtualize the network, virtualize inter-process communications or mount points or any number of other things. And what namespaces really, you kind of think of these as, for folks who are familiar with Solaris, jails, right? This is a way to basically say these processes are only allowed to see this part of the system. chroot is a very good example of a namespace. And then there's some layer capabilities. And these layer capabilities come from things like the Union file system, AUFS and Btrfs, and all these different file systems that exist in Linux. But this is how we make these virtual representations of the file. And then there's other OS functionality. And I kind of put this in the bucket of things like network plugins or volume plugins. So things that you can do in the operating system kind of as part of Docker, but not necessarily as the core part of it. The Docker engine actually has a number of different pieces to it too. And it has this layer kind of at the bottom that is the driver layer. And so what this driver layer does is it talks down to these things. So for example, Containerd is a driver that talks to the control group interface, and it talks to the namespace interface. libnetwork is their network interface. That talks a lot to the namespace layer. The graph driver is what actually understands how to say, create me a virtual directory that looks like, that's a representation of this image. So the graph driver talks to these layered file systems. And then there's all these plugins that talk to the other OS functionality, right? And so if you actually look in the Docker source code, there's all of these layers here. And then on top of that, there's the REST interface. And the REST interface is actually an API into the Docker engine. And then of course, like any good sandwich, all the meat's in the middle. So all the logic about understanding how to create these things and what does it mean for one to be running or stopped or started and all of that is in the middle of the Docker engine. And so then on top of the REST interface, the Docker client, Compose, Registry, and Swarm, all of those talk to this REST interface, right? And there's one other piece that I think is just important to talk to, and that's this layer called RHCE. And I've kind of made this a little opaque. RHCE is part of the Open Container Initiative, which Microsoft was a co-founder of, along with Docker and a number of other folks. And RHCE's job is to actually be the interface between Containerd and some of these OS functionalities below. I'll talk a little bit more about why that's important as we go forward, but this is something that's in the works now. Okay, so enough with Linux, let's talk a little bit about Windows. What does this look like in Windows? So again, we've got our operating system, we've got the Docker engine, okay? In Windows, we also have control groups. We call them job objects. We've had job objects for a number of years. They actually serve many of the same purposes, but they didn't have all the capabilities that C groups did. So we've been off making job objects a little more robust, but we've had the same kind of construct. Namespaces. Well, we actually have namespaces too. We didn't have a great way to virtualize them before. So we've built namespace virtualization. So things like the object namespace. Object namespace, for people who are thinking about it, is things like the file system, or where to get a network adapter, a hardware device, those kind of things. Or something as simple as like a mutex, where it's a named way of exchanging information between processes. These all live in the object namespace. The process table. So if I've got 10 containers running, in each container I don't want to see all of the processes from every other container. So process virtualization is the namespace for us. Networking would be another good example of a namespace. And then we've built some layer capabilities, and we've done that by building a registry and a file system filter interface for kind of creating these virtual directories, these virtual representations of a set of files. And then, of course, we also have a bunch of other OS functionality as well. So things like Active Directory and all of this other operating system functionality that we've built over many years. Now, you'll notice that in the Linux example, these were white boxes, and in the Windows example, they're blue boxes. And then I just brought this new one in called Compute Services that's a white box. The white boxes are kind of public interfaces. These are the things that we expect the public to be able to call. They'll be documented, all that kind of stuff. We built a layer on top of all of these that we call the compute services. So there's the host compute service and there's a host network service. And we built that layer because we felt like it's really important to have a common place for all of these container operations to talk to. So instead of someone having to come down to the control group and program against that API and then go to each namespace and program against that one, and then go to layer and program against that one, we give them a common place to say things like, give me a container. And so we built the compute service layer on top of that. And then we get the exact same Docker engine, but the drivers like containerd, libnetwork, graph, these actually talk to our compute service now. So they're actually Windows-specific implementations of that. The rest of the Docker engine, including the REST interface and all of the meat in the middle, remains exactly the same. So what we've done is we've changed a few of these layers. Same Docker client, same compose, same registry, same swarm, all of those things work exactly the same. They're just cross-compiled for Windows now. And then as we work on RHCE, we'll have a RHCE implementation as well. So if we actually compare these, so we'll start with Linux at the bottom, right? We talked about control groups, namespaces, layers. And we talked about Docker on the top, so we've got the client, compose, swarm, registry, the REST interface, containerd, libnetwork, graph, plugins. And then we've got Windows, right? So this is a great example contrasting the two. So we both have control groups, we both have a kind of notion of namespaces, both have some layer capabilities. We have this extra compute service, which actually looks an awful lot like RHCE, right? So we felt like this was an important layer. Turns out the rest of the community ended up thinking the same thing later on as well. And so we actually formalized some of that. And if we look at what this looks like, these are the platform-specific layers. So containerd is going to be kind of built for Windows. RHCE will be for Windows. libnetwork, we're building a Windows version of that. The graph driver for Windows. Some of the plugins will be specific to Windows. But the rest of this code above it is platform independent. It's the same code. So if someone adds a cool new interface to Docker, Docker make my breakfast, do my dishes. Boy, I'd love to see that. Then it'll just attribute to both Windows and Linux at the same time, right? Now, I talked at the very beginning, we said Windows Server containers and Hyper-V containers. So up to this point, we've really been talking about Windows Server containers. So let's talk a little bit about what those are and then what Hyper-V containers are, and so we can see some of the differences between them. So a Windows Server container starts with Windows kernel at the bottom. And then, important to all Windows, we've got a whole set of system processes. These are the things that we just don't really think about that often, but they're on every Windows server that we talk to. So things like the session manager and the local security authority and the event manager and WMI services, all of these kind of things. These are the system processes. Now, since we're running containers, we've got some container management. Say the Docker engine, and we've got our compute services that we just talked about, right? The host compute service and the network compute service. Now let's start up a Windows Server container. So what is a Windows Server container? Well, we talked about job object, so it's represented by one of them. It's got a network interface because a computer without a network is really pretty pointless. And we've got some storage and registry interaction as well. Inside of that container, we actually run a set of system processes. We run our own process instance of the local security authority. We run our own process, the event manager. We run our own copy of most of those system processes. And we do that so that each container has its own identity, its own persona. If we use the host one, well, the host has a name on the network, the container would inherit that. Not really what we want. So we run our own copy of those inside the container. And then we run whatever application processes you've specified. So if it's IIS, then we're going to run the IIS processes, W3, WP, or whatever process you want to run inside of that container. And of course, we can run many of these side by side, right? They can run the same thing, they can run different things. Doesn't really matter. But each container gets its own copy of the system processes. Now they're a copy, and because they're a copy, they're fairly lightweight. We just clone parts of those across, in effect. They're kind of referenced, so they're fairly lightweight. Windows Server container running Nano with Nano Server inside of it can start up in about a second. So we can go from nothing to start it in about 1 second. All right, so that's Windows Server containers. Now let's talk about Hyper-V containers. Now before I actually dig in too deeply into Hyper-V containers, I think it's important to understand some of the motivations behind Hyper-V containers. So we run a cloud, call that Azure. We run a lot of stuff in Azure. We run a lot of stuff for a lot of people in Azure. A couple of the services that we run in Azure, we'll pick on two in particular, Azure Automation and Azure Machine Learning. We're taking code from a customer, we're running it on their behalf in our cloud. Okay, that's great. What does the security model look like around that? Well, if I can figure out a way to trick the underlying operating system or the infrastructure around it, I could probably get some information about someone else's job that's running or trick it into doing something I didn't want it to do, right? So that's a fairly important isolation boundary to have. Well, Windows Server containers, by virtue of sharing the kernel, and so if we go back here, all these containers are sharing the same kernel. We kind of felt like that was just a little bit of a big boundary, right? Each one of these guys thinks they're administrator. They might be able to find some ways to trick the kernel into doing things. Most easily would be using more resources than we might want them to. So we invented another type of container. And so this starts with our Hyper-V hypervisor. And then of course we get the Windows kernel on top of that. Just like Windows Server containers, we've got our system processes. So this is the container host that I'm kind of describing here. And we've got our container management, right? So this is the container host, built on the hypervisor, kernel, container management, system processes, more or less the same model. But then we actually bring in a Hyper-V container. Inside of that, it's a virtual machine. It's got its own kernel. So it's got its own Windows kernel. We've got a basic set of system processes. We've got a new service we call the guest compute service. The guest compute service is the thing that understands I'm in a Hyper-V container, and its job is to actually start a Windows Server container inside. It's the same Windows Server container we talked about before. It's got a job object and a network interface and some storage and registry, all of the same things we talked about with a Windows Server container. It has a set of system processes inside, and it has application processes inside of it. But what's important about this is it's all wrapped in a nice virtual machine, a virtual machine that's designed to be run in a hostile multi-tenant environment. That's why we built a hypervisor in the first place. That's why we designed all of this to start with. So we're reusing the same technique, right? We're using that layer to give us that isolation. Now, you notice I said specifically optimized to run a container. Well, virtual machines take a little while to start up. That's been the historical case for it, right? You start up a VM and it takes 5 or 6 seconds to start up and boot all the way through. And then if you want to boot it the first time, you've got to go through sysprep and all that. Well, we specifically built a virtual machine and specifically built a version of Windows to run inside that virtual machine with its sole purpose of being to run a container. And so we get to cheat like hell because of that. We get to remove things like all of our integration services that we didn't need. We get to remove all the drivers that don't ever have any place outside of a virtual machine. In fact, even the virtual machine itself, we removed a bunch of the devices from it. We don't need most of the devices that we would if it was a general purpose virtual machine. And so by virtue of that, we can actually boot one of these up relatively quickly, a couple of seconds, all the way through having the Windows Server container started inside of it. Nested, we're even in the order of like 12 seconds. That's in a virtual machine inside of a virtual machine, starting all the way through to having a container running in under 12 seconds. And we haven't even finished doing the optimizations around that. Now, why is it that we decided to run a Windows Server container inside of it? Well, we wanted all those container images that we built to work on either one of these. So what this means is that a developer can build their container using a Windows Server container runtime, and it can run in a Hyper-V container runtime. Or you can build it with a Hyper-V container and run it as a Windows Server container. So you get to interop these things and choose which environment needs which type of container. They're the exact same API set on top. Literally the only change is when you say Docker run, you say -- isolation equals Hyper-V. Or as starting the Docker engine, you can actually pass a flag to that saying, all containers, by default, make them Hyper-V containers. I don't want to run Windows Server containers on this host. I want them to be Hyper-V containers, right? It's the exact same container image, exact same container management. Talk real quick about networking, and then I'll kick over to a quick demo. So we've got a couple different networking choices. NAT is probably the most basic. So this is heavily used for developers. Think of your home router, right? You've got a Comcast router plugged in. It's got an IP address publicly. You get like a 192 address inside your house. That's very much what NAT is. So each container gets a 172.16.0.1 address to start with. The host has an address, and it does all the routing for you. And then you can use port forwarding to allow communication outbound. This does have firewall and quality of service integration in it, so it's really an ideal solution for developers. We have another option called transparent. Transparent, it's just like a virtual switch in Hyper-V. You get your address from the DHCP server that's on the network. You can specify one as part of starting the container, but it's basically hooked up to your layer 2 network. Now this is ideal for some small environments and some development environments. My personal experience is I can start a lot of containers really fast. Turns out that it makes the DHCP server a little angry when you start up 1,000 containers over the course of an afternoon. You run out of IP addresses pretty quick, which is why NAT is my kind of preferred. And then there's L2 tunneling. This is really our software-defined network layer. So all of the software-defined networking that we're building in Server 2016, we're bringing that to bear in containers as well. So we have full network virtualization, isolated networks and services, multi-node traffic, MAC virtualization. This is really ideal for our cloud scale deployments. All right. So a couple different options for networking. All right, with no further ado, let's get to the real fun stuff. Let's get over to a demo. So as always, you're going to put in your password to get back to your machine. So this is just a Windows 10 machine. It's running, it's a laptop in my office. Nothing real special about this machine. It's a couple-year-old laptop. Now on this, I'm running a couple virtual machines. So I'm running a Windows Server virtual machine. This is one of our more current builds, and then I'm running one that's technical preview. So we'll start with this guy. It's running the full desktop with UI, and I'm doing that really just so I can go show you the Task Manager. Task Manager is kind of a useful tool for this. So that's the virtual machine running. And then what I've actually done is I've hooked up an instance of the Docker client to remotely talk to that server. So let's start a container up. So I'm going to say Docker run, and I'm going to say --rm. And that says when I'm done with that sandbox, throw it away. Don't worry about it. I don't ever want to see this container again. And I'm going to pass the flag to give me an interactive console, which is IT. And then I have to specify the container image that I want to start with. So I'm going to say Windows Server Core. Now Windows Server Core is the container image, so it's the template for this container. And then I'm going to specify the command I want to run in there, which is just a command prompt. So I'll hit enter here, and we have just fired up a new instance of Windows, right? That fast. So now we're actually interacting inside of this container interactively. So if I do a directory listing, as we talked about, we'll see perf logs and window program files and users in Windows and all of the things that we would expect to see. Now, if we look at the Task Manager, I've sorted by a new object here. This is the Job Object tab. And so we can see that there's the 792. That's the job object that all of these things are running in. So there's the command prompt, there's LASSS, there's the services. If I sorted these by name, we would see like CRSSS. We've got one that's running in no job object, that's the host one. And we got one that's running in job object 792. That's what the container sees. Now if I go over to the container and say task list, the container sees a bunch of services too, but it only sees one CRSSS. It only sees what's allowed, what its view of the world is. This is where namespaces come into play. And of course I can do things like ipconfig. There's the IP address. So again, we're talking about NAT here, 172.16.02. So it's got a NATed IP address, right? So my favorite one, reg delete HELM software. Don't try this at home. I can delete my entire registry because I'm just using a sandbox. So I've got my own copy of the registry here. Now, if I was doing this on my host, and one of these days I'm accidentally going to do this on the host, I know it. If I was doing this on the host, I would have just wiped out my entire machine, right? By deleting software once this finishes, turns out it's a pretty big key. Things like dir still work, but task list, nope, gone. But since it's been a container, I just exit back to the host. The container's been thrown away. Everything is forgotten. Now we talked about building a container image using a Docker file. So I'm going to fire up an instance of Visual Studio Code. Visual Studio Code, by the way, my favorite text editor of all time now. I think it's awesome. So I've written a super amazing little C# desktop app here. It writes out hello world. Pretty impressed, pretty proud of myself. But I want to run this inside of a container. So I've built myself a Docker file. Now this Docker file, as we talked about earlier, has a few things to it. So it says from ASP.NET 5. Now I could have pulled ASP.NET 5 right from the Docker Hub. We have an instance there. But since I'm running against a newer version of the operating system, I've made my own. And then I'm saying add in the console app, the directory, this console app directory, and then set the default command to run when the container starts to be this console app.cmd. Pretty easy. So type out my cheat sheet here. So all I'm going to do is say docker build -t, which tells it what name I want, and I'm going to call it app version 1, and I'm going to say it's in the Docker 1 directory, which is where all those things are. And so now this is sending the build context over to that host. So it's starting from ASP.NET 5, it added in this directory, it set this command to run, and now if I issue a Docker images command, I'll see I've got app 1, and I've got these other images there as well. Now, if I go back to my little cheat sheet here, let's go ahead and run this app. So Docker run, specify an RM, say an IT because I want to see the output, and there's hello world. Pretty neat. Pretty proud of myself. So I'm going to go ahead and build a little bit better app. So I've gone and implemented a new writer, my own little console write line. And if I look at the way this thing was built, I took a dependency on a new DLL as part of doing that. Right? So Dockerfile looks pretty much the same. We'll go ahead and build this guy out. So I actually had to specify no cache here. So remember we talked about layers being cached? Well, I've copied this example over a few times, and Docker doesn't know the difference anymore. The file timestamps look the same. So if I didn't specify no cache, it wouldn't actually do anything because it thinks everything looks the same. So we said no cache, and we've built our image now. Now let's go ahead and run it. So we're running version 2 of my application. Ooh, well, turns out that DLL isn't part of Windows. That's going to be a problem if I'm trying to depend on it, right? Well, turns out MSV CR120 DLL is distributed with just about everything else, like the remote debugging tools in Visual Studio. So this is a great example of it would work on the developer's machine. It might even work in pre-production, probably not going to work in production. Would have blown up. Now, as we talked about earlier, containers are versioned. I can simply continue to run version 1 of the application, and life is good. So that's great. And now we've talked about one container. Well, let's talk about mini containers. So we talked about Compose. So we're going to show an example of Docker Compose. So again, I'll open up Visual Studio Code here just to show you what I've got. And I will upfront confess this is a totally contrived example. I've got a Compose file. It says there's a web tier and a database tier. It says to build the web tier, build the web directory. To build the database tier, build the database directory. And then I've got some default networking stuff in there. So let's go take a look at what the web tier is. The web tier says pull the Microsoft IIS image. So I'm pulling this from the Docker Hub if I don't already have it. And I'm saying add this wait.ps1 script in, and I'm saying the command to start is wait.ps1. Wait.ps1 just waits for 60 seconds. That's where the contrived part of this comes in. But for an example, we'll go with it. The database one, more or less the same thing. We're pulling MySQL, the Windows instance of MySQL. We're adding wait.ps1 again, and we're setting it up that way. So that's what the compose file says. Build those, run them that way. Now we'll use my little cheat sheet so you don't have to watch me mess up typing these things. So again, I can run one command to build the whole application. So I just say docker compose build. And so this says build the web one. It's doing that right now. And then it's building the database one subsequently as well. All right, so now I've built both of them. They're both successfully built. If I was to say Docker images, I can actually see the compose web there and compose DB. It's a little bigger, so it's not as annoying to look at. Right, so we've got compose web and compose DB built now. And then all I have to do to start my application is say docker compose up -d, which says run it in daemon mode. And so sure enough, we're going to create a web container, and we're going to create a database container, and those are both started now. And so if I do docker compose ps, I get to see that both those containers are up and running. Now the cool magic. Right now I'm running one web container. I would like to run 2 web containers, please. It will automatically start up another web container for me. I would like to start 5. Well, did some math for me. It's actually only going to need to start up 3 more, so it started up 3 more containers for me. Right, so now if I do docker ps, I'm running 5 containers. Oh, and by the way, this is all running on a machine with less than a gig of memory. This virtual machine is running with 1024 meg of memory, and I can start up more. This is always where I get myself in trouble, but we'll see how many we can push into 1024 memory. So we're starting up 6, 7, 8, 9, and 10. Remember, all of these are running on one machine that's running a database, as well as now 10 web servers. Pretty neat stuff. And that is why we care about containers, right? A couple more resources for you. We've got a great set of documentation on our website, aks/Windows Containers. So this has got a whole bunch of information. Something that's kind of neat about this, if you actually go to this documentation site, it's all backed by GitHub. It's all in Markdown. So you can help contribute to making this documentation better, or you can file issues and tell us that our documentation isn't meeting your needs. And you know what? We'll go take a look at it. We'll make it better. You can also join in. We've got a great forum. So Windows Containers is a forum. People are just picking up and learning a lot about Windows Containers right now. This is a great opportunity to bolster your experience before containers become the next in-demand job for Windows like they are on Linux. Right? Linux developers and Linux IT pros that understand containers make more money than those who don't. Same thing's going to happen to Windows. So great options there. And then, of course, the resources for today, Channel 9. We've got a Channel 9 Containers channel. There's like 25 videos on there now. Continue to be adding more of those there. The virtual academies, great resource for all things Microsoft. And then, of course, TechNet and Azure for those folks. And with that, we're going to head on over to Studio B for some Q&A. So please feel free to ask questions. We'll be over there in just a moment, and we'll be taking those live. Thank you very much.
Me in my little broom cupboard. Welcome,
hey.
sir. How's it going? You're looking fly. I like the jacket.
Thank you.
Best dressed presenter so far that we've got.
Well,
certainly. Let me just make sure my mic is all ready to rock. There we go.
That usually helps, right?
Well, yeah, I was watching your presentation and then you said, oh, recap, next steps. And I was like, quick, get in here. So we are rocking. Now, again, love the suit, love the little handkerchief. Is it real or is it paper?
No, it's real.
Wow,
it's
look at
yeah.
this.
Yeah,
I was
dapper now.
When I saw you first come on, I thought, he must be going to court later on or something.
No.
He's committed an offence or something. No,
not yet.
Well, great work on the container stuff, as always. And when I was putting together the list of all of the speakers and who wanted first name on the list for containers, I thought, get this guy involved because he's been working with it for so long, and hopefully that came across in the session as well. There's nobody better placed to talk about containers from an on-premises infrastructure perspective than this guy. So nice work. We've got a few questions coming in that are coming from people watching at home. So great stuff. Thank you. Keep them coming. While we've got another 10, 15 minutes or so. So make sure you keep the questions coming if there's something burning in your mind. What did we cover in the session? We covered Windows Server containers. We covered Hyper-V containers. We covered a lot of Docker stuff. Now, people don't have to use Docker to manage the containers if they don't want to, do they? They can use alternative options. Is that right? Or?
Yeah, so we've been working with a couple of different people. So Canonical's got a project called LXD that's starting to gain some attention. We've been certainly talking to them. That whole host compute service layer that we talked about, that's the whole reason we wrote that is so that anybody could build on top of it.
Right.
So Docker is by far the most popular. That's what everything is built on top of these days.
Very mature. And
comparatively. I mean, it's mature in the sense of all of these are fairly new, but it's the most mature around it. LXD is becoming another option. And then actually as RHCE starts to formalize, and we talked a little bit about that, that's really going to be a layer for a lot of innovation to happen on top of around it.
So what things that are still in the works that you might not be able to tell us about, but in the container ecosystem in general, perhaps if we abstract a little bit, that you're most excited about? That was a question from Ted.
Yeah. Well, I mean, I think the thing I'm personally the most excited about is seeing how people actually use this in their day-to-day with Windows, right? We've seen some incredibly cool design patterns come out of Linux as people started using containers. Things like running a database right next to every website so they can cache, and some really cool things like that started coming out. I'm really excited to see how the Windows developer community and the Windows IT community takes containers and uses them for really neat and innovative things. I'm also really excited to see how much we can build on top of it. We've really just scratched the surface, right?
It's still early days. I mean, it was first introduced in Windows Server for people to play with at least, TP3, which was back in August.
Yeah.
So we evolved that with TP4, which introduced Hyper-V containers, and stuff just seems to be rolling on and snowballing as we go through the technical previews. Yeah, and I mean, we started, great examples when we started Technical Preview 3. On an SSD, the fastest SSD I could conjure up, it took about 7 or 8 seconds to start a Windows Server container. Right.
We're down to 1 second now.
Nice.
Just a hair over 1 second.
Nice. And I'm sure that will continue to improve as we go forward as well.
I mean, so it's just amazing how much we've been able to contribute on it.
Nice. And we're getting questions coming in right, left, and center now, so make sure. So containers are cool. Thank you, Chris. That's true. They are very cool. And they make things interesting for IT pros. And I think that's a good, there is more to the question, but to break it up, for me as an IT professional, very much in the realm of virtual machines and infrastructure in my previous IT life to this point, it's certainly a mindset change, and you've almost got to snap yourself out of virtual machines, because if you start to apply some of the principles, you confuse yourself still further with containers. But they are cool, but Chris's question really is about what applications we'll actually be using. What are some of the most common? Is there a running list of things? So he mentions, or lists, Microsoft apps, vendor applications, so partner applications, F/OSS applications. Is there a list of container-compatible applications? Give some insight into that for Chris.
So we are trying to compile a list of things that we've tested, things that work on our container documentation site. And as I mentioned earlier, that's something people contribute to, so feel free to add more to it. The far and away most common app that I talk to people about is web apps. Right. So I want to run my web app, I want to be able to scale it, I can run it inside of a container. Life is good. Now, really quickly, that extends to, well, I've got a middle tier for that web app, so I'll bring that along for the party. I've got a database for it, so I'll bring that along to the ride. But these are a lot of apps that people are developing in-house. Certainly, there's examples of things like WordPress, of apps that are kind of canned and pre-boxed that people run in production as well. But far and away, all the apps that people have, that they've been developed by consultants or in their environment are the ones that we hear the most about. Right,
and do you see, another question from Kenneth, who was with us earlier on the previous session as well, do you see software vendors using containers as the basis for a new software deployment model? So could you see vendor X, who traditionally builds MSI-based applications, deploying now as here's the container, and you just run that in your environment?
I think there's going to be two battling worlds. One is going to be using things like Windows Server applications, right? I think Rafat talked a little bit about that. So Windows Server applications being a packaging model that you then as a Docker file install in your container. We see this a lot in Linux today. And then those get pushed up to a Docker hub. The advantage of that is that you're not confined to a container at that point. If you wanted to run it in a VM, you
Yeah.
certainly could. But we are hearing a lot of interest from ISVs and saying, gee, it'd be really nice to just package up everything together. Here's a container, set of container images with a compose file or some mesosphere metadata. Here's how you run my stuff. And it's been tested and validated, and it works that way.
And it works on everyone's machine.
Yeah, and you can
incredibly
demo it
cool.
on your laptop, and I can take it into the data center and scale it.
Nice. So in terms of differences between the different types of containers, not specifically Windows Server containers and Hyper-V, because you covered those in the session, but somebody has asked, Bill in fact has asked, what are some of the key differences between containers with Nano Server, stroke Azure, stroke Windows Server 2016? So I'm assuming he's asking, if you run them in the different places, is there a fundamental difference?
Sure. So the container host can either be Nano Server, Server Core, Server with Desktop, where obviously Nano Server is really going to be our the ideal scenario for running these. And those are going to run in Azure is a virtual machine. So you get a set of virtual machines, one virtual machine, 5 virtual machines, 50 virtual machines running Nano, and your containers can run across those. Now those will be able to be Windows Server Core or Nano Server containers. So we can actually run either operating system in the container. So at RTM, you'll be able to actually run a Server Core container on top of Nano Server.
Nice.
It'd be pretty neat.
But it would still have to be Windows on Windows. So another question we've got from Christian is, can I run a Linux-based container image on a Windows Docker engine?
And no, they've got to match.
Yeah.
But it's the same Docker engine, same APIs. So
the management experience would be unified.
So we showed this at DockerCon. We had a Swarm cluster. So remember, Swarm is what aggregates all the nodes.
Yeah.
We had some nodes that were Windows and some nodes that were Linux.
Nice.
We deployed an application that had a Linux backend and a Windows front end. The Linux containers go to the Linux nodes. The Windows images go to the Windows nodes. Your application's none the wiser.
Nice, nice. And so how would you recommend, and this is a good question that I want to make sure that we always give in these interview sessions, how do you get started? What's the best way to, where should somebody go?
So very end of the session, I had a link up there. It's aka.ms/Windows containers. That is our documentation site. Right in the middle of that is getting started. So we've got 3 different scripts. You can either get started on your own machine. So we'll create a virtual machine. We'll put Windows in it. We'll download it all. We'll orchestrate it. It takes 30 or 40 minutes to run through. But at the end of it, you've got a virtual machine running Docker in it. You can get one in Azure. So we've got an Azure image up there. Or you can build your own by just downloading Windows Server. And we've got some examples of how to use containers as part of that as well.
And there's some great videos on the Containers channel on Channel 9 as well. Well, don't point at me. You were involved as well. So myself, Taylor, Neil Peterson, a good hat tip to him as well. We've been doing a lot of work to help educate you on containers, because it is, and we've had a question here from Andy. Not a question, but I'm so confused by containers. It does take a couple of, the first time you embrace it, it does take a couple of iterations to get it straight in your mind. And I almost find, and my advice would you, building on what Taylor said, is just follow the instructions on the documentation side, just walk through it. And it does become a lot more easy to understand as you start to do it yourself. And you don't need big hardware requirements or anything. You could run it on a VM on your laptop very easily. Very, very straightforward. So I'm guessing the answer to this question is around something you've already mentioned, but what is your personal favorite use case for containers?
Personal favorite use case for containers. I mean, I think, what I'm just seeing as we're talking to customers who are building this stuff out is how much it's changing the developer IT pro mindset. So taking things from developer and moving them into production without the friction that's involved there. And it's kind of a broad answer, because that means anything that you're building could be done in containers.
But that's what we want people to do. We just want people to use it and embrace it and do different things and explore and innovate themselves.
It's kind of, it's for me, it's going from a handsaw to a skill saw, right? Like, I can still cut the board with the handsaw, but man, it's a lot faster to just run that through with a power tool.
Yeah, nice. Always good to have a power tool analogy.
Got to have one.
Well, it's the first one of the day. Can you RDP into a GUI stroke Explorer for a container like you can spawn a bash prompt in Linux? From Eric.
So we do not have RDP. We had it in Technical Preview 3. It is not in Technical Preview 4, and I don't believe we're going to have it in RTM.
Okay.
The reason that we originally had it in Vision was for GUI-based applications, so we can click Next and kind of go through them.
Yeah.
Completely breaks the Docker build experience.
Right.
And so we're really pushing for automated ways to do that, so that we get
more
that
alignment
full,
with containers on other platforms.
Right. Well, and so we get that full experience around it. Right. Now, over time, I could definitely see some interesting use cases for client-based or GUI-based containers, but for right now, we're going to start with server containers, and then we'll continue to iterate.
And do containers apply, another question from Tim this time, do containers apply to Azure PaaS and Azure IaaS or only on-prem?
So they're definitely on-prem.
Yes.
They are more IaaS than they are PaaS, but they're actually this really interesting place in the middle. They're kind of halfway between. So with the Azure Container Service, we can spin up a set of container hosts. That's kind of PaaS-ish, but you're not as confined to the Azure APIs. You can build your own stuff and just kind of run it in there. So it's kind of a neat mix of both worlds.
Right, and so a question slightly different then. So you could run on Azure IaaS if you want today. I think there's guidance on the MSDN documentation that walks you through setting up a VM on Azure for that. But in terms of if somebody did want to install an app into a container, how would somebody do it with an MSI?
So we actually have a whole bunch of examples of just this.
Right.
So on our documentation site on the GitHub, we've got examples. But you just run MSI exec/q or whatever the command line flags are for that application to install it silently in a silent fashion. Now there are some apps that don't have that. Those are the apps that we need to go push a little bit on those folks to help us add unattended options to.
Okay. Now, a question to help clarify, I think, for some people from another Mats. It's a good questions coming from Mats today.
Yeah.
I'm not preferential treatment at all.
Sure.
I feel like I'm still missing a key component. Using the website example, how will containers handle situations where a website has an uploads directory? If those files live in the container, won't they be blown away if we update the container image?
So we talked a little bit, and I went through this kind of fast, volumes. So volumes allow you to map a directory into the container from the host. So now if you stop the container and start another container mapped to that same volume, same files are there.
Still there.
And actually multiple containers can use the same volume. So you can actually have 3 containers on the same host all pointing to that same volume.
And no matter if you destroy one container, bring another up, they can just point to the same stuff. So those upload files, in this case for Matt's question, would still be sat there, persistent.
Right, yeah. And there's some really cool, we talked about volume plugins. There's one from Cluster HQ called Flocker. Great name.
Yeah.
And what Flocker actually does... I can't believe
where they come up with the idea for that.
I know. What Flocker does is it does data management of those volumes. It moves volumes around as part of starting and stopping containers. Really cool stuff to take a look at too.
Nice. Do Windows Server containers have a NetBIOS PC name, and can they be joined to a domain? If not, how does one handle those file share permissions?
Great question. So yes, they do have a name. You can specify it at startup time if you want to, or you can just use the auto-assign one. In terms of joining it to a domain, we aren't going to have it joined to a domain because that kind of defeats some of the purpose of the portability.
Yeah.
What we are working on is a really cool thing. We'll be talking more about this at Build.
Right. Stay tuned.
For giving containers domain identities.
Right. Cool. And that's all we can say for now.
Yeah, we'll talk about it more at Build.
Okay,
so
I think you've planted the seed there. Yeah, stay tuned. And stay tuned on the containers channel as well, leading up to Build. We're working on some more material there on channel 9. Remember the documentation, aka.ms/Windows containers, and you can find the documentation with the videos. And can people contribute to the documentation?
Absolutely, it's all in GitHub.
Yeah, there you go. So
the new Microsoft
exactly.
open in GitHub, yeah.
There you go. So to wrap up this session, thank you, sir, for your help. It's been a pleasure, and thanks for Taylor for helping us through the containers content. We wanted to ask a question before we go to the next session, which is going to be on Operations Management Suite and how that can provide lots of insight into your infrastructure and your data, no matter where it resides. And the question is, so stay tuned for Joe's session, is what is the daily upload allowance for the free tier of the Operations Management Suite? And remember, to enter, you've got to be following ms_IT Pro, #TechNetVC, #contest, answers when you can. And we'll see you again soon. Enjoy.